Good morning, students. This is the third class of chapter 3, Energy, and we have studied about the energy, work, formula of work, and the factors on which the work depends, and the units of work, and the that units of energy. Okay, so now revise these topics in brief. Energy. What is the energy? Energy is the ability or the capacity to do work. Clear? Work, what is work? Or when we can say that work is said to be done. So actually work and energy both are correlated. Okay, so when a force causes displacement in its own direction, work is said to be done. And what is the formula of work? Formula of work is force into displacement, or mathematically it can be expressed as F into S. Okay. And what are the factors on which work depends, or we can say that what are the factors determining the work. Okay, so work depends upon the force applied and the displacement of the body in the direction of the applied force, or we can say that for doing the work two conditions are necessary. First condition is there must be a force acting on the body, and second condition is the body must move in the direction of the applied force only. Clear? Now, what are the units of work? So, in SI system, unit of work is joule. And for the numerical purpose, we can convert it into Newton and meter. So, 1 joule is equal to 1 Newton in and 1 we can say that 1 joule is equal to 1 Newton into 1 meter. Okay. So now what is the unit of energy? So the old unit of energy is calorie, and or we can say that kilocalorie also. But in these days, energy is measured in joules, not in calories. Thus, a conversion was needed as calories is an outdated unit. Okay, that is why work and energy has the same unit, because energy is the capacity or the ability to do work. Okay, and work is the force, or we can say that the product of force and displacement. Clear? They both have the same unit. Clear? Now we will see the remaining topics of this unit. So some numericals are left. So now we will do the numericals which are based on the work, and we'll see the back exercise also. Okay. So our first numerical is calculate the amount of work done when a force of 30 Newton displaces a body through 25 meter in its own direction. Okay, that means what we have to find? We have to find the work. How much work is done when a force of 30 Newton displaces a body through 25 meter. Now you have to see that what is given and what we have to find. So first in the solution, first we will write all the values which are given in the question. So 30 Newton, if you are confused that which quantity is given, you can find the quantity by its SI unit. Newton is the SI unit of force. So force is given in Newton, that is 30 Newton. Displacement, it is denoted by S, it is given 25 meter. Actually displacement is the shortest distance only, so it will come in meter. Okay, so displacement S is given as 25 meter. Now we have to find work done, and we know that the formula of work, and it is denoted by W. W is equal to F into S, where F is the force and S is the displacement. Okay, now we will put the value which are given in the question. So what is the value of F? That is 30 Newton. And what is the value of displacement? It will be 25 meter. So after solving this, we'll get the value of the work done. It will be 750, and Newton into meter, and already we have seen that N into M is equal to J, that is joule. So work done will be 750 joule. Clear? Now the second numerical is a work of 450 joule is done when a force of 15 Newton is applied to a cart. Clear? That means work, the value of the work is given and the value of the force is given. Okay. Now what is to be calculated? Calculate the distance through which the cart moves. That means we have to find the displacement. All the numericals of this unit, we have to use one formula, that is the work is equal to force into displacement. Okay, so now in the solution we'll write all the values which are given in the question. Work done, W is equal to 450 joule. Force is denoted by F, that it is given 15 Newton, and distance or displacement, it's to be calculated. So by applying the formula of the work, we can find the value of displacement S, and it will be work upon force. Clear? And after putting all the values of work and force, 450 joule upon 15 Newton. Clear? So after solving this step, we'll get the value of displacement. Displacement is denoted by S. So it will be 30 meter. Clear? And our next numerical is a work of 15 joule is done in moving a body through 2 meter. Okay, that means a work of 15 joule, that means work is given and the displacement of the body is given. Okay, in the direction of the applied force. Clear? Now what we have to find? Calculate the magnitude of the applied force. That means work is given, the displacement or the distance covered by that body is given, that is 2 meter, and we have to find the applied force. Okay, so in the solution, first we will write all the values which are given in the question. Work done, W is equal to 15 joule. Distance covered, or we can say the displacement, S is equal to 2 meter. Clear? And applied force F is to be calculated. So applying the formula of the work is equal to F into S, and we have to find F. So we will change their places. So F will be W upon S. Now we will put the value of work and displacement, and here it will be 15 joule upon 2 meter, and after solving this, the force will come as 7.5 Newton. This you have to remember, that if you are finding the force, the answer should come in Newton. If you are finding the displacement or the distance, the answer should come in meter, and if you are finding the work, it should come in joule. Okay. Now this is turn to solve the back exercise, exercise 3.1. Now the objective type question, our first question is fill ups, and the help box is given. So first question is, the object which does work loses energy. Okay, so answer will be loses. Second one, the object on which work is done gains the energy. Okay, so answer will be gains. Third one, a boy carrying heavy school bag and standing still. Standing still, that means he is not changing its place. Okay, standing still does no work, because when we can say that work is done when the force is applied and displacement should be there. Here force is applied by the bag, but boy is not moving, or boy is not changing its place, so no work done. So the answer will be no. Fourth one, the work done by a body is the product of force and, yes, displacement, F into S. So answer will be displacement. Fifth one, dash is the old unit of work. So calorie is the old unit of work. Okay, so answer will be calorie. Now true false, an old unit of energy is calorie. Yes, true. First one will be true. Second one, the product of force and the displacement caused by it is called power. No, it is called the work. Clear? So second one will be false. Third one, a student preparing his lessons for monthly test does mental work. Yes, it is called the mental work, not the physical work. Okay, so third one will be true. Fourth one, a boy carrying a school bag on his shoulder does work. False. He is not doing any kind of work. Clear? Fifth one, if the displacement caused by a force is at right angles to the direction of the applied force, the work done is zero. Yes, it will be true. Fifth one. Clear? Now next question is statement given below are incorrect. We have to correct the statement. First statement is given as work is done when you hold a heavy suitcase in your hand. So there is no work done. Only you are holding the suitcase, but you are not changing your place. So no work is done. So at the beginning of this sentence, you have to write no. So it will be no work is done when you hold a heavy suitcase in your hand. Clear? Second statement is work done by a body is the product of power and displacement. No, it will be force and displacement. So at the place of power, you have to write force. Clear? Third one, work is or we can say that work is done when a force causes displacement at right angles to its own direction. No, in that case, work done is zero. So at the beginning of this statement, you have to write no. So it will be no work is done when a force causes displacement at right angles to its own direction. Clear? Fourth one, a teacher taking a class while standing does work? No. If he or she is moving or roaming in the class, then we can say that work is done. But in that case, there is no work done. So at the place, or we can write in between does and work, you have to write no. Clear? So it will be a teacher taking a class while standing does no work. Clear? Fifth one, the SI unit of work or energy is calorie. No, calorie is the old unit of energy. Clear? But the SI unit of work or energy is joule. So at the place of calorie, you have to write joule. Clear? Now choose the correct answer. First one, the ability to do work is called energy. Many times we have seen that. Okay, so the correct answer will be C, energy. Clear? Second one, the work done by a body is the product of displacement and yes, force. Force and displacement is work. So the correct answer will be C, force. Third one, an old unit of energy is calorie. So in third one also the correct answer will be C. Okay. Fourth one, 50 joules work is done when a force F causes a displacement of 10 meter. The magnitude of force is this can be the homework because you can solve this as we have or as we did in the numericals. Okay, work is given and the displacement is given and you have to find the value of force. So the correct answer will be B, 5 Newton. You can find or you can solve this. Clear? So correct answer will be B, 5 Newton. Fifth one, when is the work done in the following situation? Okay, four situations are given and we have to find in which situation we can say that work is done. First situation is given a girl pushing a wall. Clear? Second one, a boy carrying a suitcase in his hand. Third, a stone falling freely. Clear? And fourth, a boy climbing up the stairs. What will be the correct answer? D. In D, third and fourth situations are given and third and fourth situation we can say that work is done, because stone falling freely, there someone is throwing the stone, that means force is someone is exerting the force and the displacement is there. Then we can say that in third condition also we can say that work is done. And fourth, the boy is climbing up the stair, he is exerting the force and he is displacing also, or we can say that he is changing its place. So in both the condition, that means in third and fourth, we can say that work is done. So the correct answer will be D, third and fourth. Clear? Now match the following. First one, force into displacement. Yes, work. So the answer will be D. Second one, the ability to do work is called energy. So the answer will be C. Third one, an old unit of energy is calorie. So the correct answer will be B. Fourth one, displacement caused by a force in its own direction. This is the condition for work done. So the correct answer will be A. So here I am finishing this unit 3.1. I hope you understood. In our next unit, we will see the kinds of energy. So that's all for today's class. Thank you.